what should happen? And as a fraction, it's the number of favorable outcomes over the total possible outcomes. Favorable means what we want, what we're asking for. Experimental probability. What actually happens when you conduct an experiment? So it's the number of successes out of the total number of trials. We did experimental probability where we were pulling things out of a bag. The Skittles. So the theoretical probability was how many greens did we have in there? How many oranges did we have in there? The experimental probability was how many greens did we pull out? How many oranges did we pull out? That's the difference. This is what should happen based on what's in there. This is what does happen based on what you do in your experiment. Independent events. Good. When one event does not affect the outcome of the other. Can you repeat that about independent events, please? When one event does not affect the outcome of another event. That's like flipping a coin and rolling, dice. Dependent events.
Of another.
When one event does affect the outcome of others. What were the key words for dependent events?
A deck of cards. Well, never mind.
Okay, when you're pulling something out of a bag and you want two of them, but what's happening when you pull one thing out of the bag and then you go to pull the next thing out of the bag? I'm taking one out and I am not doing what? I'm not replacing. Without replacements. Those were the key words that we need to know. And when we do this, we also need to keep in mind to multiply. Add that to that little foldable there. Multiply. Can I flip?
Yeah.
Okay, it'll be online if not. Possible combinations. List all the possible combinations of tossing a coin, rolling a die, and spinning an equal section color spinner, red and blue.
I think I flipped mine.
All right.
Is this how it's supposed to be?
Mm-hmm. If I flip a coin, what can I get?
Heads or tails.
Heads or tails.
More heads and heads, tails and tails.
Well, that's if I'm flipping 2 coins.
Oh.
If I roll, what can I get?
1 through 6.
And if I spin,
Red or blue.
Why is they back like flipped like this?
because it's just how they were printed. I didn't print them out, so I made it do what it do. That's why I had them rooted in a certain way. How many options do I have here? 2. How many options do I have here? 6. How many options do I have here? 2. How do I find the total number of combinations? Multiply 2 times 6 times 2. Was 2 times 6? 12. Was 12 times 2? 24. Is all of these combinations possible? How do I make these combinations? What can I get for all 3 of these events? What's one example of one thing from all 3 events? Robert. Okay, do we start counting with 3?
So 1.
Heads 1
3.
and blue. What else can I get? Treasure? Heads 2 and keep the same color. You got to keep something consistent. Blue, besides the heads. What else can I get? Heads 3 and blue. What else can I get? Heads 4 blue. Do you see why it's a good idea to start with 1 so you can go in a sequence or pattern? Because if I started with 3, then I would have had to say, okay, well, did I do 1? Did I do 4? Did I do 5? No, just go in order. So 5 would be next. 6 would be next. And it would be head 7 blue too, right?
No.
Why not? Because there's not 7 sides there. So now that I've done heads and blues, now what do I need to do? I can do tails and reds, but then I also need to do heads and reds. So why don't I do get all the heads out the way? Head 1, red. Head 2, red. What's next?
Head 3 red.
Keep going.
Head 4 red.
Keep going.
Head 5 red.
Keep going.
Head 6 red.
Stop. Now I'm done with all of the possible heads combinations. How many is that?
12.
12. I'm halfway there. Now what does that mean I have to do?
Tails.
I have to do tails. And everything else can stay the same. So I can do tails 1 blue, tails 2 blue, tails 3 blue, all the way to tails 6R. I've done my blue. Now the red. 1. Now it's time for lunch. We're making a sample space using the tree with the same options. I have heads or tails, so I'm going to put heads at the top branch and tails at the other top branch. Then if I flip a heads, let me see it. If I flip a heads, what can I roll on the die? What else?
Red.
No, what else can I roll on the dice?
6.
1, 2, 3, 4, 5, and 6. Okay? So, what do I need to add branches for, and what needs to be at the end of them?
You need to add branches for the dice at the end of the color.
So, what options do I have? 1 through 6. So, I need branches here. 1, 2, 3, 4, 5, and 6. I offset them for a reason. One is short, one is long on purpose. After I roll after I roll a 1, what color can I spin? Or, so then I need both options, red or blue, to go with each number, red or blue. And then you need to do the same thing for tails. Looking at the examples that they've given you, we're going to have to flip it over. If a bag contained 4 red, 3 black, 2 orange, and 4 blue, what is the probability Greg drew a red marble, did not replace it? You can't see it. Why are y'all saying that? Did not replace it, and then drew an orange marble. What's important? He did not replace. That's important. 4 red, 3 black, 2 orange, 4 blue. I want red first, then orange. So probability in probability notation is red, then orange. How many are red? 4. Is that it? What do I have to do? Okay, which is what? No, I don't have to do them all. I know y'all are not playing right now. Do I just write 4 and be done? Nobody's looking in their notes. I'm not doing the thinking for you. You've already been taught this material. Hey, hush. Okay, 13 is the total number of marbles in that bag. That is 4 red. Have I fully answered the question?
No.
What else are they asking about?
The orange marble.
Orange. What is the probability of getting orange?
2 out of
There are 2 oranges. The 2 part is correct. How many marbles are in the bag?
13.
If you take one out that's red, then how many are in the bag?
12.
You need to understand they said did not replace. I'm not putting that marble back in. I don't have 13 in there anymore.
2 over 12.
Then what do I do with these 2 fractions?
Multiply.
Multiply them. Simplify 2/12. 4 times 1. 13 times 6. Simplify again. What do 4 and 6 have in common? 2. So what's 4 divided by 2? 2. What's 6 divided by 2? 3. I should have simplified before multiplying. 2 times 1 and 3 times 13.